Breath holding. Breath holding is the first stage of drowning, where you hold your breath for as long as you possibly can. It's instinctive. You're underwater, you're struggling, and you're desperate to buy time. But as your body keeps burning through oxygen, panic starts creeping in. Carbon dioxide, the waste gas your body produces, builds up in the blood. This condition is called hypercapnia. As carbon dioxide rises, it makes the blood more acidic, a change known as respiratory acidosis. Because carbon dioxide reacts with fluids in the body to form acids, your body can't let this continue. Eventually, the urge to breathe overwhelms you, and an involuntary inhalation reflex kicks in. Inhalation and water entry. When the inhalation reflex finally kicks in, you can't stop yourself from gasping, and water can rush into your airway. Protective structures that help keep the airway clear during swallowing, such as the epiglottis, which is a small flap of tissue, and the vocal cords, which close the windpipe, are helpful but not foolproof underwater. The moment water slips past, your body often tries to fight back with a violent cough. Coughing can sometimes expel water, but it is frequently ineffective and may be followed by further aspiration. In some cases, the vocal cords spasm shut in a reaction called a laryngospasm, or the small airways tighten in a bronchospasm. These reflexes are desperate attempts to keep water out, but they can also block airflow and stop effective breathing. Either way, you are not ventilating properly. As seconds pass, more water may enter the lungs, oxygen levels fall further, and the situation spirals quickly out of control. Hypoxia. Hypoxia is a condition in which there is an inadequate supply of oxygen to the tissues to sustain normal cellular function, which is why this stage is sometimes described as the brain being starved of oxygen. The brain weighs only a few pounds, yet uses a large share of the body's oxygen, about 1/5, so it is especially vulnerable. Without enough oxygen, brain cells called neurons begin to fail and then die. As this happens, you first lose coordination, then consciousness. Reflexes that once made you gasp stop working. Your body is shutting down piece by piece. Although the adult brain can make a small number of new cells in certain areas, most of the widespread neuronal loss caused by prolonged oxygen deprivation is effectively irreversible. Brain death. Brain death occurs when prolonged oxygen deprivation causes irreversible damage to the brain, making recovery impossible. When large numbers of neurons die, vital areas such as the brainstem, the lower part of the brain that controls breathing and basic reflexes, stop functioning. This results in the loss of coughing and gag reflexes, pupil reactions, and the ability to breathe independently. When all brain and brainstem activity is irreversibly lost, a person meets the medical definition of brain death. There is no detectable brain activity, no brainstem reflexes, and no spontaneous respiration. Machines may temporarily sustain the heart and lungs, but the brain itself has permanently ceased to function. Although specific procedures and confirmatory tests vary, brain death is legally recognized as death in most countries. If you like this video, subscribe for more.